Hello everyone, this is MD Azizul Islam from University of Texas at Arlington. Today we will discuss about the experiment regarding determination of specific gravity of soil. In this experiment, the specific gravity of a given soil sample will be determined by water pictometer method. We will follow the ASTM D854 standard. The soil sample less than 4.75 mm can be determined with this method. However, soil with high organic content and soil which floats or dissolves in water cannot be determined with this method. Specific gravity indicates how much heavier or lighter a material is compared to water. The specific gravity can be determined as the ratio of the mass of a unit volume of soil to the mass of the same volume of gas-free distilled water at 20 degrees Celsius. In this definition, the two important term is the soil sample, the water occupied by the soil sample should be gas-free and the water should be at 20 degrees Celsius. If the temperature changes, then we need to report the specific gravity at 20 degrees Celsius. This is the standard temperature to report a specific gravity. The typical range of specific gravity for different types of soil is shown in this table. The type of soil can be determined from the laboratory obtained data of specific gravity. For example, if you find the specific gravity of a soil sample is around 2.64, then you can say that the soil sample might be sand. In the phase relationship of soil, specific gravity plays a very important role. Knowing the specific gravity, the relationship among different unit weights, void ratio, and porosity can be derived. This table shows some relationship of the phase diagram of soil. So, what will be the unit weight of the specific gravity? Since this is the ratio of the density of soil solids to the density of water, the units will be cancelled out by each other. Hence, the specific gravity is a unitless term. So let's discuss the methodology of this experiment. At first, we need a 500 milliliter clean and dry volumetric flask, which is known as water pictometer. Carefully fill the flask with de-aired distilled water up to the 500 milliliter mark. Measure the mass of the pictometer filled with water. Also measure the temperature of the water in the pictometer. After that, keep approximately 2/3 of water and empty the rest of it. You can conduct this experiment into two ways. The first way is one can take exactly 100 grams of oven dry soil sample. That way you don't need to determine the weight of the dry soil later. Just make sure that you put all the soil samples in the pictometer. The second method is that you can take an approximate weight of soil samples like 100 grams of soil, but after the test you need to oven dry all the soil samples and take the final and exact dry weight of the soil. After putting the soil into the pictometer, you need to remove the air bubbles by applying vacuum with a vacuum pump for at least 10 minutes. After that, fill the rest of the pictometer with water. Take the weight of the pictometer filled with water and soil sample. If you follow the second procedure, then you need to oven dry the soil sample for at least 24 hours. Measure the weight of the oven dried sample. For the calculation part, we can determine the specific gravity of soil sample with this equation. In addition, we need to apply temperature correction factor in this formula. The value of the factor A can be determined from this following table. So let's start a sample example of the calculation for determining specific gravity. So from the testing result, we have recorded three weight data. The first one is mass of flask filled with water. Second is mass of flask filled with soil sample and water. And the third is mass of oven dry soil samples. We also recorded the temperature of the water. From the previous table, we can easily determine the temperature correction factor. In the end, if we put all the values in this equation, the specific gravity of soil can be determined at 20 degrees Celsius. Specific gravity is a basic property of soil sample which is necessary to compute soil's void ratio and for determining the grain size distribution in hydrometer analysis. Here are some YouTube video links which will be helpful for in-depth concept for this experiment. Thank you for listening to this lecture. Hope to see you in the next experiment. Thank you.